Hello everybody. My name is Gratz, as you heard. I'm a sales manager for a large conglomerate, international conglomerate that's engaged in the waste energy space. And I'm a mechanical engineer by trade, and fortunately for society I never engineered anything. I was always in the technical sales side of things, and as you can tell by my Arnold-esque accent, I'm not born and raised in the United States. I actually grew up in Europe, Austria to be specific, and environmental stewardship and recycling was something that was put in my cradle, basically. I remember when I was a little child going with my parents to the main square and recycling glass in the early 80s. And not only glass as such, but green glass from white glass, from brown glass. In later years, when I was a Boy Scout, we once a month volunteered to drive around with some farmers around town and pick up bundled newspaper from residences and then bring it to a recycling place. So I grew up with that. And this is kind of like where I want to go with my talk today. I want to raise awareness that recycling is, we're familiar with the plastics and the glass and the paper and such, but there is another way of recycling out there, which is organics recycling, and not a lot of us have heard of that. So with that, I want to go into a couple of statistics here. The World Bank has come up with some numbers here that in 2018, globally, we have produced about 2 billion tons of waste, municipal solid waste. And it's expected to be about 3.4 billion tons by the year of 2050. Having said that, we realize that waste is outgrowing population growth. And there's a couple of reasons for that. One of our, obviously, is population grows by itself, but there is increased urbanization and there is economic growth that contributes to that as well. What the really sad part is that only 20% of that waste globally is actually brought to a higher and better use or being recycled. And that is quite alarming, actually. Most of that waste ends up in landfills. What is a landfill? For those of us that don't know, landfill is essentially a hole in the ground where we bury waste. And it can be as primitive as a ravine somewhere in developing countries, at the edge of town where we dump our waste onto. Or it can be something like a systematic burial ground of waste that's lined with industrial tarps and that has daily covers on it and final covers on it in more industrialized nations. But the fact of the matter is that landfills have a big problem. When organic waste, or waste in general, but especially organic waste, is decaying, it produces gas. It's called landfill gas. Landfill gas is about 50% methane, 50% CO2 or so. Now, we all know that CO2 is a measure how we measure greenhouse gases. What a lot of us don't know is that methane is about a 20 to 30 times worse greenhouse gas than CO2 is. And it's much more effective for trapping heat within our environment, and therefore significantly contributing towards greenhouse gas emissions. So 5% of all greenhouse gas emissions come from the waste sector globally. By 2050, it's expected that about 2.4 billion tons of greenhouse gas will be emitted just from the waste sector. And that equates to the emissions of about 500 million passenger cars. To put that into relation, there's currently supposed to be around 1 billion passenger cars roaming the earth. So it's a staggering number, right, really. So landfills historically have been very cheap, because it's cheap to just throw it somewhere and then put some dirt on it. However, they're becoming more and more expensive. So the space for landfills is running out. They're becoming rare, and once a landfill is full, that's it. It's very hard to permit new landfills. Also, the maintenance of landfills to comply with environmental regulations that are getting tougher and tougher, especially in industrialized nations, is becoming more and more expensive. And operations of those landfills does not cease when the landfill is closed or it's full. There has to be operation staff on site for decades afterwards to make sure that leachate doesn't get in the groundwater, and to make sure that the emissions are capped somehow or collected. So it becomes very expensive. But really the important part is here that we have to realize that landfills are unsustainable. We are really wasting human habitat. We are polluting our groundwaters and our atmosphere. We are increasing emissions because these landfills typically are way outside of town, out of sight, out of mind, where nobody can see it. So we have to truck our waste far distances and create emissions that way as well. And really, by the end of the day, we're not recovering the ecological and economical benefits of a resource that we're literally burying in the ground. And that resource can be used in many different ways. So, focusing a little bit more on the United States here, the United States is actually the third largest producer of waste globally. Amounts to 11-something%. What we have to realize, we only make up about 4.4% of the global population. So we are a very large polluter. It's the throwaway society. You know, you just get some Amazon packages, there's plenty of waste in there. And in the United States, what it looks like is that about 15% of the methane emissions that are created are coming from municipal solid waste, basically. So that's staggering. In 2018, it was calculated that we produced about 292 million tons of waste in the United States, and about a third of that is actually organic in nature. And those organics are only recycled to a very small extent, about 11% of it, and traditionally done with composting of green and yard waste and such. And what ends up happening is we still dispose about close to 60 million tons and even more in landfills, with organic waste in landfills. And we are not using that resource hardly at all. And that organic waste in the landfills produces enough emissions to equate to about the emissions of 21 million passenger cars. Quite a staggering number. CalRecycle estimates that in California alone we're burying about 6 million tons of organics per year. And methane emissions from those landfills can actually be, or could theoretically be used to decarbonize our fossil fuel-based energy grid. We're all familiar with this logo here. We've seen it on every plastic piece that we ever held in our hand, and packaging pieces. In a circular economy, we aim, number one, to reduce waste, reuse it for a higher and better use, and really by recycling. So reduce, reuse, recycle. So organic waste, what is it really? Organic waste comes from a number of different sources. One of them is, of course, animal-type manures, some agricultural waste. There is also yard waste. We are living in an area where we have 2 growing seasons almost, and there's a lot of yard waste that's created. And then food waste. And where does food waste come from? About 40%, 43% or so come from our households. It's food that's expiring, the kitchen cuttings from when we're cooking, takeout food that ends up in the refrigerator that we never eat and end up throwing out. There's also commercial sources, which come from grocery stores, restaurants, large food establishments, such as Cal Poly, for instance, or the large prison that we have in town here. Smaller amounts from the farming community, from crops and stover and such, and very little amounts from the actual food production side of things. So how can we take this waste, this organic waste, and use it beneficially for us? So traditionally and historically, we have used composting, particularly for yard waste, to create a nutrient-rich soil amendment, which is great, and especially great when you have it at home. It's easy to do, put it in a little barrel, turn that barrel every once in a while, and we create a nice thing, soil amendment that you put on your roses. That's fantastic. However, if you do it on an industrial scale, this composting operation becomes a net energy sink. And what that means is that I have to spend tremendous amounts of energy to do the composting properly. If I don't do it properly, then I will create greenhouse gas emissions. So I have huge pieces of equipment that are burning diesel that turn over these compost piles. They're called windrows, and they're 30 foot high and 30 foot wide, and they're burning a lot of energy. So composting by its nature, when it's properly done, is a net energy sink and producing the soil in, which is great. An alternative method, a more advanced method, dare I say, for treating organics would be anaerobic digestion. And what anaerobic digestion really is, it's a breakdown of organic matter with microbes. And those microbes are in an oxygen-free environment. That's where the anaerobe comes in. As, basically, remember or just imagine a big metal stomach, if you will. And that anaerobic digestion process creates biogas. We all heard of solar, wind as alternative resources for energy. Biogas is kind of the stepchild. But this biogas is very beneficial. It can be used to decarbonize our energy grid. And during the anaerobic digestion process, only about 20% of that energy that's created is actually used to sustain the anaerobic digestion process. So I have 80% of this biogas left that I can do something with, which is great. So anaerobic digestion is a net energy producer, basically, while still producing a organic soil amendment that we can use in farming. What does biogas look like? It's about 60% methane, 40% carbon dioxide, as compared to our natural gas that comes out of the pipeline in our stove. That's about 98, 99% or so methane. So it's what we call a medium BTU gas, but it still has energy content that can be beneficially used. I'm not going to bore you with this slide too much. It gets a little bit technical. I just want to tell you about, there's two major technologies, if you will, in anaerobic digestion. There's wet digestion technology, which most of us are familiar with without even knowing. If you drive down the road by a wastewater treatment plant or so, you see a big round tank with a bubble on it, and that's a wet digestion, basically. That's primarily used for wastewater treatment or liquidy type substances that are pumpable. They cannot handle high contamination substances like solid waste, for instance, or they cannot handle yard waste. So that's why dry digestion was invented. And dry digestion can handle high contamination and high solids type feedstocks that are not pumpable, that are actually stackable. So I was talking about energy in biogas, What does that really mean? So 1 ton of organic waste creates about 4,500 standard cubic feet of biogas, and that's the engineer in me. Most of us don't know what that really means. But that same ton of organic waste, if you make it a transportation fuel, can produce the same amount of energy as 26 gallons or 24 gallons rather of gasoline, and which could power a car for about 680 miles or so. That same ton of organic waste can, when electricity is made out of it, produce about 320 kilowatts of electricity, which is enough electricity to power an average home for about 10 to 15 days or so. So that's all good stuff. So really, to come full circle here, what most of us don't know is that in San Luis Obispo here, we're actually practicing what I'm preaching here. There is an anaerobic digestion facility that's been operating for about 4 years now. It's located on the south side of the airport. And this facility has been operating since September of 2018. And that's where our green bin material goes. If you own a home, you most likely have a green bin where you put your yard waste in and also your organics from the kitchen. And this facility processes about 36,000 tons per year of organics, which amounts to roughly about 100 tons a day. And it really helps San Luis Obispo County to meet the state-mandated diversion goals of organics. And that's quite significant because there is a State Senate Bill 1383 now that's been in force since 2 years that really mandates that organics have to be pulled out of landfills and brought to a higher and better use. So we are doing that in San Luis Obispo already. We're producing about, with this facility here, 6.2 million kilowatt hours of electricity, which is enough electricity for about 600 homes. And it removes effectively about 5,300 metric tons of CO2 equivalent. That's a unit of measure for greenhouse gases. But what that really means, it removes the emissions of about 1,000 cars out of the atmosphere as far as greenhouse gases. So just a brief walk through the process here. Don't worry with the details, but what happens is the trucks come in, dedicated organic trucks that collect this organic waste. They dump it on a receiving floor, if you will. The material is pre-treated, some contaminants are removed, it's ground up a little bit, and then it goes into the steel vessel, that horizontal tube that you see there. And over the course of 14 days and 131 degrees, this material advances through this vessel, produces biogas. The microbes produce the biogas, release it. It's collected in that little blue headspace up top there, and then the biogas is siphoned off to a biogas consumer. In the case of San Luis Obispo, it's a big engine that the biogas is used as a fuel to turn a generator that produces electrons, and these electrons are then fed onto the PG&E power grid. About 80% of the material that's not converted into biogas is coming out this discharge and compost side, and that is actually converted into an organic compost soil amendment that's used in local vineyards, for instance, local agriculture, to produce and help retain fertile soil. And also a liquid soil amendment that's used in agriculture as well. And these two soil amendments actually help reduce the use of fossil fuel-based fertilizers, believe it or not. So not only are we creating renewable gas, we're also displacing some fossil fuel-based fertilizers, which of course is a great thing. So with that, I will conclude my talk here, and I really appreciate you all's time. And I hope I was able to convey a little message here to you that we as a society really have to look beyond the traditional recycling trajectory that we're all used to and really incorporate organics recycling into our approach to create a more sustainable future, to protect our land, protect our water, protect our air, and really leave this place a better place for our descendants. And remember this talk the next time you eat a banana, because that banana peel, before you throw it in the regular trash, throw it in the green bin or in the organics bin, that banana peel can power a 60-watt light bulb for about 1 hour. So with that, I thank you very much.